All right, happy Wednesday, and we are going to continue with our division lesson 12, dividing four-digit numbers. Today, our problem says a factory has 2,125 DVD players to ship to electronic stores. They ship 4 DVD players in each box. How many full boxes can they ship? So, essentially, we are doing the problem 2,125 divided by 4. And we're trying to figure out what does that equal. That's going to tell us how many boxes they can ship. Now, we have two different ways that the book gives us an example of. You can use an area model to help you understand the problem. So we're trying to figure out our unknown, the question mark. 4 times what number gives us 2,125? So we're going to break it down into our different boxes that represent place value. So in our 100 spot, we're asking ourselves, 4 times what number can get me as close as I can to 2,125? And they've done the work for us. 4 times 5 equals 2,000. So 4 times 5 is 20. Add our 2 zeros at the end gives us 2,000. Now, what do we have left over after we do that 500? We only have 125 left. So we're going to move it over here to our next place value. 4 times what number gets us as close as we can to 125? 4 times 25 equals 100. Think of like quarters or 25 cents. If you have 4 of them, you have $1 or 100 cents. So once we figure out what we have left over, we still have 25 left over. And we are not done until our leftover is less than this number. So 25. 4 times what gets us as close as we can to 25? They've done the work for us. 4 times 6 is 24. 25 minus 24 is 1. Now, our 1 is smaller than this number. So that tells me I'm done dividing, that I can no longer multiply anything times 4 and fit it in this number. So my remainder or my leftover is 1. When I add up these red numbers on top, I get 531 with a remainder of 1. There's my answer in number form. But we also have to realize what that means in our problem. So we're going to talk about that too. But here is a different way that we can do the problem. This is a lot like the hangman division, except I draw my line all the way down and write my red numbers over to the side. They're just writing their red numbers on top. Okay? Divide each place value of 2,125 by 4. So, first we're going to work on that 1,000 spot. How many groups of 4 in 2,000? 500. So, if we put our 500 up here, that is 2,000. Next, how many groups of 4 in 100? There's 25. Then our leftover is our 25. If we do 4 times 6, we get 24. And our leftover, our remainder, is 1. The partial quotients are 500, 25, and 6. The quotient is all those numbers added together, 531. The sum of the partial quotients, the remainder is 1. So what do all these numbers mean? That's what we're going to talk about right now. Number 7 says, how many full boxes can they ship? So if we go back to our story problem, we know that it was asking how many full boxes can they ship. Okay, well, how many full boxes can they ship? They can ship 531 boxes. But what does the remainder mean in this problem? We have one left over. One what left over? One DVD player. What does the remainder mean? We have one leftover or one extra DVD player. That leftover DVD player didn't fit in the box. So if the factory could ship partially filled boxes, how would the answer change? So if they could ship a box that was not all the way full, they would ship how many boxes? 532 boxes. Only one box would only have one DVD player. It wouldn't be a full box. How is the partial quotients model on the previous page like subtracting partial products model in the field trip problem? So let's find our field trip problem, just like yesterday. So we subtracted partial products here. How is that like subtracting partial products on partial quotients on this page? So on this page, we subtracted the numbers that we multiplied together. And on this page, we subtracted. Okay, so how is the partial quotients model like the partial products? So first of all, we need to understand that partial quotient equals the partial is parts, quotient is linked to division. So I'm going to put parts and division to help me keep it straight in my mind. And the partial products is parts and products is multiplication. Okay, I couldn't fit it all on there, but now I understand a little bit more of what this question is asking me. So how are they similar? How are partial products and partial quotients similar? Both of them, we are breaking down the numbers into smaller, easier to understand pieces. Because I don't know off the top of my head, what 2,125 divided by 4 is. But I could figure out what 2,000 divided by 4 was. By using the trick with the zeros, I can figure out that it's 500. So if we break it apart into easier to understand pieces, that's all partial quotients means. Which division model do you like better? Subtracting partial products, or finding partial quotient, or the area model? Explain how that model helps you divide. So, which do you like better? Do you like to use that multiplication trick? Do you like to figure out how many groups are in a bigger number? Or do you like to break it down into each piece like this? So that's what you're going to write for number 11. Go ahead and pause the video until you're done with number 11. We're going to go ahead and do these two on a separate piece of paper. So I'm going to grab a notebook. And I'm going to write number 12 is 1010 divided by 9. And we're going to try that one first. So I'm going to go ahead and set it up. Make sure my notebook's in the frame. I'm going to set it up, and I know I put my 9 on the outside and my 1010 on the inside. Now, how many groups of 9 fit in 1000? I'm going to say if I have 10, I have 90. What about 100? 100 groups would be 900. That's a good starting point. I like using those numbers with 0. So let's see, if I have any leftovers, I'm going to do 10 minus 9 to get 1. So I have 110 as a leftover. So I know I can fit more groups in there because this number is still smaller than this one. Let's see, if I do, now I can do 10 groups of 9. 10 groups of 9 is 90. 11 minus 9 is 20. If this number is still bigger, I can fit more groups of 9. So now it's going to have to be less than 10. What about 5? 5 groups of 9 is 45 because 5 times 9 is 45. So 5's too much. What about 3? 3 times 9 is 27. 2 times 9 is 18. If this number's smaller, I can't fit any more groups of 9 in there. So that's going to be my remainder. And then I'm going to figure out what my what the quotient, what the answer is. 100 plus 10 plus 2, 112. So I'm going to write up here as my answer, 112 with a remainder of 2. All right, now I'm going to try number 13. Number 13 is 5,783 divided by 6. So I'm going to go ahead and set up my problem again. 5,783. All right, my very first step. How many groups of 6 can fit into 5,000? If I try 100, I know it's going to be 600, so that'll fit. Can I fit another 100 into that? I think so. What about, I don't want to keep adding 100 so many times that I run out of paper. What if I do 200? 200, and I can even make a little note over here. 6 times 200 is 12 with 2 zeros. That'll definitely fit in there. What if I do 400 groups of 6? 6 times 4 is 24 with 2 zeros. That's, oh my goodness. Okay, so let's try 400 groups of 6. I don't want to keep adding 100 a million times. Let's go higher. So 2,400. 3, 8. All right, I'm going to borrow here. 11 minus 4 is 7. 4 minus 2 is 2. Whoa, I can do that again. Three, 8, 3. Wow, so now I only have 383 left. So I can't even do 100 this time because 100 groups of 6 is 600. And I only have 300 left over. So, what if I could do 10. Could I do 20? 30? What's 30 groups of 6? 30 groups of 6 is 18 with a 0 on the end. 3, 0, 2. Oh, I can do 30 again. 180. 3. I'm going to cover that up so I can see 20 minus 18 and easily know that that's going to be a 2. Ooh, 6 times 4 is 24, but I don't have enough, so it must be 6 times 3, which is 18. 23 minus 18. Sometimes it helps to count up. 18, 19, 20, 21, 22, 23. So that was 5 fingers. Now this number is smaller than that. There's no way I can fit another group of 6 with what I have left over. So this is going to be my remainder, and I'm going to add these together. Wow. 500, 963. 963. So when I write my answer, I'm going to make sure not to forget my remainder of 5. So there is division with remainders. This way, if you're doing hangman division, you can do it. We could have all solved this problem a different way and still got the correct answer. So we are going to continue to work with division, and I will see you guys in small groups.